Okay, this is the P3 paper from January 2021. It's question number 6, and we can see that we've got some differentiation in here, and it looks like we're going to be using the product rule to solve that bit. And then the rest of the question is numerical methods. So we've got some work on iteration and location of roots. Let's make a start then, part A. So the function fx was given by fx equals x cos x over 3, which straight away we can see is a product. We're going to set u as being equal to x, and we're going to set v as being equal to cos x over 3. Hopefully both easy to differentiate. Du by dx is equal to 1, and dv by dx, the differential of cos is minus sine, but then we also have to take account of the fact that it's x over 3, so it becomes minus a third sine and then x over 3. That should not really be causing you too many problems by the time you're coming to do exam questions. F dash x then, product rule is u dv by dx plus v du by dx. I always write them down so it helps me to remember them. Doesn't matter whether they're in formula booklet or not, we need to be on top of the product rule, quotient rule, similar sorts of things. So f dash x then is going to be u dv dx is those two, so that's, I'm going to write that all together straight away, minus x over 3 sine x over 3. Let's not take too many steps to do that. And v du dx is those two, which are just cos x over 3. Excellent. Okay, so that's that bit just done straight away. 2 marks for that. And it now says, show the equation f dash x can be written down like this. And the thing that jumps out at me is arctan, or tan to the minus 1, which makes sense if I've got sine and cos. Sine over cos is tan, so I'm pretty okay with how I'm going to approach this one. F dash x is equals 0, means that all of this thing is equal to 0 plus cos x over 3. Oops, that's all equal to 0. And so I now need to rearrange this. We're going to get x over 3 sine x over 3 is equal to cos x over 3. And now I want to get tan to the minus 1. I'm going to get arctan. So I know that I've got to have sine over cos here, which means dividing that one. I'm also going to take this over to the other side, and just be careful with that. If you're taking x over 3 over to the other side, dividing means that we're going to end up with this. The sine should be okay. Sine x over 3 over cos x over 3. But here, in effect, you're going to invert that now, aren't you? One way to think about it is that's going to come up and that's going to go down. Whichever way round you do it, as long as we end up with that as the next step. So that is tan x over 3 is equal to 3 over x. And now we know that we were going to do arctan, or tan to the minus 1. So I'm going to get the x over 3 on this side. I'm doing tan to the minus 1 of both. So I'm doing arctan of both sides is going to equal arctan 3 over x. And I'm nearly there. The answer wanted it in the form x equals. So x is going to be equal to 3 arctan 3 over x. So if we go back and look at that, yeah, that's in the correct format. K basically is equal to 3. Let's look at the part C then. Part C says, starting with x1 equals 2.5, and using that formula, in effect, we found the iterative formula there by doing all that work. Starting with x1 equals 2.5 and the iterative formula, calculate x2 and x6, giving your answers to 3 decimal places. Right? This is relatively standard with the way that they do this, and they have this sort of gap here between the values. So I'll just show you the way that I set it out. So they've told me that x1 is equal to 2.5, and x2 then is going to be putting 2.5 in. That's the whole point about iterative. You'll just keep plugging your answer back into the function. I'm only going to show it once though. I'm only going to show on this one that if I want x2, it's 3 arctan 3 over, now putting that value in there. So I've shown that I know how to do the method, and that comes out to be 2 points. Now they said to 3 decimal places. I'm just going to put as many as I want really. It doesn't matter down here. I did them all to 6 decimal places when I was doing it. Is that, but then equals, they've asked for this specific one, so 2.628. I must do that. I've got to do that. That's my answer for that part. But then x3, x4, x5, and then x6. I'm not going to keep rewriting that out. That takes me too long, especially for so many of them. All we're doing is now plugging this answer back in, getting an answer out, plugging the new answer back in, and getting an answer out. So I can do that all on my calculator without writing anything down here. So x3 worked out to be 2.554102. x3, when I put 2.554 back in, works out to be 2.596527. And I'm putting the whole number back in. I'm only writing down however many decimal places, 5, 6 decimal places here. Sorry, I'm trying to write and talk at the same time. When I got down to x6, it worked out to be 2.586122. But then that one, just as like with the x2, they wanted that to 3 decimal places. So 2.586. And that's all the work that I would actually write down in terms of doing this part C. It's worth, how many marks? Let's have a look. Yeah, it's only worth 2 marks. You don't want to be writing too much, but obviously you've got to keep it accurate in terms of what you're plugging in. Right, part D. What does part D say? It says use a suitable interval and a suitable function that should be stated to show that the root of that is 2.581 correct to 3 decimal places. Yeah, so no problem with that one. What we're going to do is we're going to simply put in, sorry, where are we? If we want 2.581 to 3 decimal places, what we need to do is to show there's a root between the upper bound and the lower bound of that. If the root lies between those two, then no matter what, it must correct to 2.581. So all I'm going to do is put the upper bound into the function and the lower bound into the function. What function am I going to be using? I'm going to be using that function there. That's the function for f-x. So that's explaining it to you. I now need to explain it to the examiner. So let me just do that. And they said, first of all, tell me what the function is. So I'm going to use f-x equals, and then the function's going to be the differential that I had from before. So minus x over 3 sine x over 3 plus cos x over 3. That's the function I'm going to be using, the one that would have been equal to 0 in that first part. And now all I'm going to do is I'm going to try that. And again, this is how much I would write down. I'm going to try that for the lower bound, and the lower bound is 2.5805. Now you could just put the value in here. A lot of the time I would just put the value in here. I'm really more just reminding you guys of this. So it's minus 2.5805 over 3 sine 2.5805 over 3 plus cos 5805 over 3. And I'm expecting that to be really close to 0. Yeah, this works out to be 0.000346. Right, fantastic. If one of them works out to be small and positive, when I do the same thing for the upper bound, then what I should get for the upper bound is that it works out to be negative and quite small. So I've basically got to repeat this work again. I'm going to use a little bit of magic of the iPad here just to save me a little bit of time here. So now I'm not going to be using 2.805. I'm going to be using the upper bound, which is 2.85815. 15 and 15 in there. Because I'm using the iPad, I'm prepared to write this out again. If I was doing it in an exam, it would very much depend on how much time I had left and whether I'd made any mistakes on any previous questions, because you could simply have written this down without that bit writing. It's not getting you any extra marks, really. For me, it's more a question of reminding myself of things like the fact that the angle there has to be in radians. We were told it was in radians at the start of the question. Right, I explained it to you, but to make it a better explanation for the examiner here, I always write this bit down as the end of these types of questions. I'm saying, since there is a sign change, memorize this, guys, and f-x is continuous, that's going to be enough pretty much to get you the marks here. There is a root alpha, where alpha is between those two things that I just set up, which was the upper bound and the lower bound. I could write. There's a root alpha which lies in there, and if it lies in there, therefore alpha has to be 2.581 to 3 decimal places. Remember, they've told us the answer, haven't they? So if we look at that in its entirety, I'll just make it a bit smaller so you can see it. But if we look at that, all of that, that's a good answer to that part D. If you're running out of time, they told us to do that bit. I didn't have any choice but to write that bit down, but I would have got rid of that bit and that bit if necessary and just had f-2.5805 equals to that one and f-2.5815 equals to that one if you didn't have a lot of time. Definitely, I would always be writing that bit in. So hopefully that will make sense, and it's a relatively straightforward numerical methods question.